Morning. Today we are going to discuss about the subject on solid state physics. So in this solid state physics, I choose the subtopic dielectric laws. So first you have to know about what is meant by dielectric laws. Before we go into the dielectric laws, first of all you know that what is meant by dielectrics. We know well about the dielectric is nothing but a insulating material. So the dielectric are otherwise called as insulating materials. So many dielectrics are there, plastics, rubbers, wood like this. So in this video, so we are going to derive the dielectric laws. So which means dissipation of energy. In the form of heat. When we apply the AC voltage or electrical energy to the dielectric material. So in this situation, when we pass the DC, the AC current or electrical energy to the dielectric material, there is a consumption of energy in the dielectric material, and it, what happens then it becomes dissipated. It's in the form of heat. In the form of heat it gets dissipated, which is called as dielectric loss. When we pass electrical energy or AC current to the dielectric material, the energy will become dissipated in the form of heat. We call it as dielectric loss. So this is the simplest circuit diagram for finding the dielectric loss. This is a dielectric material. When we pass the current with the help of AC, so there is a creation of loss in the form of heat. It is called dielectric loss. So we can split up into two cases. First one, here we chosen here ideal dielectric material. Ideal dielectric material. What happened when we choose the ideal dielectric material? What happened for the dielectric loss? There is no loss will occur for the ideal dielectric materials. How it happens? When we consider the phasor diagram between current and the voltage, it creates 90-degree phase angle between the current and the voltage. Now you find out the power loss. You know the formula: power equal to voltage into current, angle factor cos theta. Here we substitute the angle theta equal to 90 degree. What happened? Cos 90 will become 0. So anything into 0 you can get 0. So which indicates, which reveals that there is no loss will occur for the which material? Ideal dielectric material. Ideal dielectric material. So for ideal dielectric material, we can't be able to find out the power loss, which means P equal to 0. So then what about the commercial dielectric material? Commercial dielectric, case 2, we can consider the commercial dielectric material. For this commercial dielectric material, the phase diagram between voltage and current like this, I, V. This we denote the angle, loss angle, dielectric loss angle. So this is the theta. So from which this diagram we find out the phase angle del equal to 90 minus theta. Yeah, the whole which represents 90, and this gives the theta. You can get the del. You have to subtract 90 minus theta, then get the del value. Now we are going to find out the power loss P equal to VA cos theta. Here you substitute the angle. There is a theta equal to del VI cos 90 minus theta. You change, we consider the del. So P equal to VI sin, there is a del. You can put as del sin del and get the sin del. So P equal to VA sin del. So one more condition we are going to apply. In case this commercial dielectric which is placed between the capacitor, so based on that we can write the relation I equal to V by Xc. We know the Xc value, Xc equal to 1 by 2 pi Fc. So on substituting this value I equal to V by Xc, where Xc equal to 1 by 2 pi Fc into this equation, we get the final solution. Here Xc which represents the capacitive reactance. So which is compared with Ohm's law I equal to V by R. It is directly proportional. X is nothing but a resistance for capacitance. We call it as capacitive reactance. Now substituting these values into the previous equation, we get V square 2 pi Fc time del. One more condition we are going to apply. When the phase angle is very very small, we take an sinus tan del. P equal to V square 2 pi Fc tan del. So this is our final power loss answer for the commercial dielectric material. So P equal to V square into 2 pi Fc tan del. So this power loss is directly proportional to V square F frequency applied C capacitor, then phase angle del. So this is the final expression for power loss, which includes when we use the commercial dielectric material. Okay, so first you know the dielectric loss. What is meant by dielectric loss? It's nothing but the dissipation of heat energy when we apply the electrical energy or DC current into the dielectric material. Then we have to split up into two cases. For ideal dielectric, what happens? For commercial dielectric, what is the value for power loss? As we well know, when we use the ideal dielectric, we get P equal to 0, which reveals that there is no dielectric loss was created in the ideal dielectric. Or we can easily visualize with the help of phasor diagram also, we can easily visualize there is no loss created in the ideal dielectric. Whereas in the commercial dielectric, there is a power loss P equal to V square dot 2 pi Fc into tan del. Since there is a phase difference between current and voltage, somewhat the current which lags behind the voltage of angle, which means 90 minus theta. Okay, so from that we can find out the del equal to 90 minus theta here, del which represents the dielectric loss angle, del which represents the dielectric loss angle. So finally we can find out the power values P equal to V square dot 2 pi Fc tan del. Okay, thank you.